Welcome back to the Digital Math Tutor. We encourage you to subscribe. As you can see, we provide tutorial mathematics classes for junior primary pupils, junior secondary school students, senior secondary school students, adult learners, and for kids preparing for external examinations. So in today's video on this channel, we'll be looking at the introduction to binary system. If you look at this topic, it's a topic you can see in the first term of SS1 students maths work. Yes, and also you're going to see this particular topic in the senior primary classes too, though depending on the level you're looking at. So it's a math that cuts across. So whatever grade or level you're operating, I think this is also for you, including adult learners. So as a parent, subscribe to this channel and let your children learn. These are free resources, and we came up with this in order to help every one of us. So quickly, I'm going to just introduce binary to us. Listen to this video. You're not only watching these graphics moving here and there, you are listening, because listening is very important. There are so many things to talk about binary, but this is an introductory video, so let's quickly go through this. I'll be talking and I'll be writing as well. Now, when we talk about binary, when you hear binary system, binary, look at the word binary. The word by, that particular prefix called by, indicates two. So in a very simple term, binary system of numbers, of numbering or numerals in mathematics is a base 2 number system. It's one of the systems used in computer engineering. Yes, that's where you see this. The binary is purely a computer engineering, a code. But here in mathematics too, we use it. For me to help you to understand binary very well, I want to understand number systems. Presently, the kind of number system we use almost all over the world as it stands, we use regularly in mathematics, is what we call the decimal system. And that decimal system is base 10. That's what we call base 10. A lot of people don't understand these things. Yes, we use all this things often. Binary is called base 2. Are you getting this? It's called a base 2 system of counting, of numbering, of numerals, indicating numerical values. Now, base 10 is decimal, and that's the one we're using. So anytime this base 10 has only 10 digits, every number you see, no matter the size of that number, whether in tens, in units, in millions, in tens of millions, in tens of thousands, are made up of any of these 10 digits. And that's why we call it base 10. Look at it. You are talking about 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 of this. You see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 digits. So any number you want to form must be a combination of one or more of these numbers. You want to say, I want to write 123. You are bringing this. You are writing 10,578,999. Everything you are mentioning must be a combination of this. So that's the decimal system. But in binary, you can only see 2 digits. And those 2 digits are 0 and 1. Anytime you see any number, a number formation that has anything more than 0 or 1, even in 2, that number is never a binary. So any binary number must contain only 0 and 1. And that's why it's base 2. You have only 2 digits that make up any base 2 system, 0 or 1. That's why you might see a number system like a number combination like 0110. This number is in base 2. Without no, every student should understand this. Even those of us who are teachers that teach our children mathematics, we have to understand this. Explain this thing very well to the kids. Parents, you understand. So anytime you see any number that has a combination of 2 or more, or a bigger number in it, that number is not a binary, because every binary number must contain 0 and 1 only. That is exactly what it is. It must contain only 0 and 1. Like you see this number I've written here now, this number is what? Is 6. It represents 6. Now, remember, I'm talking about, introduction to binary. So there are a few things I'm going to help you know. Now, the question is, if I want to represent a particular number under binary, how do I do it? Yes, we have formulas, but I want you to see, I want to show you a tabular guide. And every formula you see we are dealing with today came out from this tabular guide. And that's how it works. Now, let me draw this table. It may not be that long, it may not contain so much. Okay, let me draw this. I've just made this table just 5 columns. Now, remember we're talking about base 2 number system. Let me tell you, we still have base 3. We have base 4. We have base. These bases are not common. Base 2 binary is one of the commonest, because if not anywhere in use, like I told you, the computer engineers, they use it. It's a popular language code for computers. So it's a popular code that is used. That's why you see it being popular, as well as the decimal system. That is base 10. Another popular base is base 16, which we call hexadecimal. So these 3 bases are so popular because they are being used in different fields of learning. You understand? Now we have base 3, we have base 4. Every numbering system, you can have all their bases. Yes, at least they, from counting from 1 to 10, even 16, even to 20, we have their bases. And we need to understand these number bases, how they work. Now, every number base starts from the power 0. Now, let me show you something. If you write 2, okay, let me write it here because of space. 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2 raised to the power 3, 2 raised to the power 4. If you are a teacher teaching binary, it's easy for you to explain these things to your kids this way than dragging them into the formula altogether. Every number, listen to me, you are also in this pure mathematics class we do here. So actually, when you are teaching mathematics, you might be teaching a particular topic. There's no way it's not going to drag you to something else. So as children listen to this video, you learn as well. Don't say we are learning only binary. You're going to hear me say some things that will guide you too. In mathematics, when we talk about indices, which is, all these numbers being raised to power this and power that, that is what we call indices or exponential. Every number, any number in this world raised to the power 0, the answer to that number or whatever, the final outcome is 1. So 2 raised to the power 0 is 1. 1 million raised to the power 0 is 1. Children must know this. There are certain areas of mathematics you must so master and it becomes part of you. You don't need teachers to revise it, often and on. No, it should be. So when you walk into exam hall and see any number raised to power 0, you don't need to say, do I? No matter the size of that number, you know that it is 1. Now, another thing we'll understand when it comes to indices, that any number raised to the power 1 is that number. So 2 raised to the power 1 is 2. The same thing, 1 million raised to the power 1 is 1 million. 10 billion raised to the power 1 is 10 billion. Do you understand that? Meanwhile, 10 billion raised to the power 0 is 1. Get the gist. This video, why video is so good is, even if you think I'm fast, you can watch and go back, watch, take it easy. You can repeatedly listen to what I am saying. Now, this is 2 raised to the power 0, 2 raised to the power 1, then 2 raised to the power 2 is 4. 2 raised to the power 3 means 2 times 2 times 2, which is 8. Then the other one was 16. If you get the next one, 2 raised to the power 5 is 32. 2 raised to the power 6 is 64. Then 128, 256, 512, 1024, and just like that, 2048, 4096. Just, are you getting this? That is how it is. Children should understand this. Now, it's very simple. If I have this, you understand? I now know that every powers of 2 goes in this range. 2 raised to the power 0, 1, 2 raised to the power 2, 2, 2 raised to the power 1, 2, 2 raised to the power 2, 4, then 3, 8, and all that. So I'm having 1, 2, 4, 8, 16. Do you understand? So if I'm giving a number in a decimal form and asked to convert it to, let's say, convert it to a binary, that's the base 2. Let me give you an instance now. I have this. Let me put it like this again. Remember that here I have 1, 2, 4. In my format table, I'm bringing this from 8, 16. Let me add 32 here, please. Are you getting it? Now, if I'm given a particular number, for instance, I'm asked to find 17. Are you getting it? I'm asked to find 17 and convert it to a binary number in base 2. Remember, 17 now is in its decimal form. It's in base 10. Yes. That's what it's saying now. Yes. Now I'm asked to convert it to base 2. From this table, look at what I'm going to do. 32 is already bigger than 17, so nothing goes there. What you see here is 0, which is invariably nothing. So the first 6, since 16 is the next number after 17. Remember the number in this table, the biggest one here is 32, and 17 is less than 32, so 32 can never be part of it. So the first number that will go here is 16. I put 1. Anyone that will enter, you put 1. The one that will not enter, you put 0. This wisdom, this is the best way to teach binary for students, for learners. Even adults, you can learn that way. Now, I ask myself, having added 16, I'm looking for 17, remember. I've added 16. If I add 8 to 16, it will be more than this. Am I right? In fact, having added 16, I ask myself, out of 17, what remains when I add 16? Only 1 remains. So 8 can never go. So I add 0. Again, 4 can never go. I add 0. 2 can never go. I add 0. The next thing that will go is 1. Look at it. 16 plus 1 is 17. So the binary formation of 17 is 10001. It's as simple as that. Do you understand it? And this is exactly how this is. If you take other numbers, you can do the same thing. So this is a brief introduction to binary system. I'm going to stop this video at this point. I wish you the best. Please remember to subscribe and keep visiting. Share this video. Let others know in the group where you belong. Let others be part of this. I wish you the best. God bless you.